What you're about to see is a true story demonstrating the problem-solving methodology of value engineering on a project involving installing a fire detection system in an occupied historic mansion. The scope of the project was to install smoke and heat detectors in every room, closet, basement, and attic space of this mansion, and also to provide manual fire alarm pull stations at the stairwell door on every floor. This is what the smoke detectors looked like. The smoke detectors that were used were ionization type. Each smoke detector cost approximately 15 times that of a heat detector. Smoke detectors are much more sensitive than heat detectors, which require the heat of flame from a fire to set them off. The more smoke detectors you have in a project is deemed to represent a higher quality installation. When we received this project to Value Engineer, it was given to us as a Mission Impossible challenge. The boss didn't think we could do it because he had attempted to design it 3 times. The first bid came in at 130% over the budget set by Congress for residential improvements in any one year. The second design reduced quality to a minimal acceptable level by substituting the cheaper heat detectors for many of the more desirable smoke detectors. And the third design eliminated detectors in many spaces not considered primary occupancy. This was a stretch of the code just to get something done, for surely the fire would not start in a closet. The first roadblock we encountered was a cost roadblock. It was said that the project couldn't be done for the price demanded. The mansion was too big and too ornate. Well, VE methodology teaches a number of accelerator techniques to take care of roadblocks such as this. The first technique is to put $1 on the main idea. The second technique is to evaluate the entire project scope by function, by creating a function cost model, which is just what we did. We began this study by preparing a cost model of the original project as bid, which was for $23,000. We noticed that the basic function of the project, detect fire, represented only 11% of the project cost, and 54% was being spent on the secondary function, transmit alarm, and 2/3 of this, or $8,500, was to alert the guard. It seems that a direct burial cable going outside the house and across the road and under the landscaping was being used to transmit the alarm to the guardhouse, who would then call the fire department. We brainstormed many ways to perform the alert guard function, but all were rejected for one reason or another. One of the best ideas on our list was to use the telephone. It was said that some telephone operator could cut off the service at any time, even for reason that the bill wasn't paid for 1 month. Well, this called for the use of another accelerator technique. We did this by getting information from the best source. We contacted the telephone company, lamenting the unreliability of their service. They said, "No way, use an LLA. It will monitor your line and signal when it is not operating. Then you can post a guard in the house until it is restored again." Well, I said, "Great, I'll take one." They said, "We don't sell them. You'll have to get one from the detector equipment manufacturer." Well, back at the office I checked the fire equipment catalog and it didn't show one. So I called the manufacturer of the detectors in New Jersey. They said, "Sure, we have LLAs. They just didn't print that page in the color catalog because they don't sell very many." Use of the telephone already in the house and the purchase of the lease line annunciator got the VE study off to a great start, reducing construction costs by $7,800 without sacrifice of quality or performance. Someone else would pay the $24 per year telephone charge. We were part way there, but still needed to save another $5,200 to reach the $10,000 budget limit. So we were left to try to value engineer the rest out of the inside of the house itself. From the design, it was obvious that all detectors had been placed in the center of every room. We also noticed from our field trip the crystal chandelier in the center of the dining room. When we asked the electrical engineer about the apparent conflict, he said, "Oh, they'll just move the detector over 6 inches. Now won't that make the rooms look beautiful?" Getting all the facts, we contacted the fire protection engineers, who told us that the detectors didn't need to be in the center of every room. They could even go on a wall. Just keep them 12 inches away from the ceiling or wall to provide for air circulation around them. That's what we were told. The project drawings indicated that all the runs of conduit and wire came from the basement, up the walls, and out into the center of the rooms. At least we could shorten the runs out to the center of the rooms. But could we do anything about the upfeeding? Blasting away at this was fun. What if the power started anywhere you wanted it, even in the sky? Would that be of any benefit? Well, if the team had its way, the power would start in the attic. The scope of the project was to install smoke and heat detectors in every room, closet, basement, and attic space of this mansion, and also to provide manual fire alarm. In the attic, all conduit could be run exposed, and one could punch through the third-floor ceiling and place detectors anywhere. And outside the lines of the attic floor, we could run into dormer space to get to the second floor. Yes, being in the attic had great advantages. One of the ways to reduce cost is to reduce the quantity of devices to be installed. This also helps to reduce the amount of conduit and wire that are needed to be routed throughout the house. The fire protection officials wanted bells in every bedroom and on every floor, a total of 11 bells. Looking at standard ways of making noise for fire alarm systems, we used 4 horns, which when going off simultaneously throughout the house was sure to wake the dead. Combining all the ideas that we've learned to this point, this is the layout where the detectors were located when downfed from the attic. This roadblock caused the contractor to cut chases in the plaster walls and ceilings to bury the conduit out of sight. The detectors had to be mounted on electrical boxes. To recess these in the ceiling required the cutting of precise holes in the old plaster, which would crumble upon touch. When all this damage was done, it had to be repaired. However, the house was beautifully covered with custom wallpaper. Imagine trying to patch the strips of paper and paint. No way. We were redoing the whole room, and almost the whole house. One way to avoid cutting and patching was to invent a new way of concealment of conduit. In our judgment, we thought that exposed conduit hidden in a closet behind the clothing was in effect concealed, and if the front corner of the closet, even better. This solution, combined with placing the detectors off-center in the room, effectively eliminated the need for all cutting and patching. From the attic, we downfed the conduit through the closets below. On the second floor, this is where the detectors came out. Notice there is no horizontal wiring. Everything is vertical. The VE team challenged materials and substituted 1/2 inch EMT for 3/4 inch rigid conduit. We even used BX in the attic. But surprisingly, we ended up using more linear-feeded conduit by downfeeding rather than upfeeding the wire. So we spent more money on conduit. But the drilling of holes only allowed us to hang the detectors on the end of the conduit pipe rather than fasten them to the ceiling. This contributed to our real savings. Our last problem with mounting the detectors came from a manufacturer's statement that only the octagon box will fit the detectors because only its two mounting tabs would line up with the holes in the detector base. Needless to say, applying another accelerator technique worked. Searching the bins of a local electrical supplier, we found a wire mold box that had tab spacing that would fit the detector, provided that one of the tabs was bent down out of the way. Use of this final accelerator technique led to our proposal to surface mount the detectors and overcome the roadblock. Since the wire mold box was only 1/2 inch deep and fit the detector snugly, it could be painted oyster white and would look fine high up on the ceiling. We took one to the mansion and got approval from the lady of the house. Using a ladder, we held it against the ceiling so she could evaluate by comparison. The first floor of the mansion was the showroom floor for visitors and guests. The resultant strategic placement of the detectors won the day and had many project advantages. The original $8,000 cost to preserve property was reduced to $1,200 without the sacrifice of function. But even more important, we had eliminated all craft trades but the electrician, who by union rules could drill holes and spray paint the mounting bases. We rebid the project to electrical contractors rather than general contractors as prime. The bids this time came in $1,800 below budget. The cost of our basic function, detect fire, increased by $900 and represented 41% of the cost. Much better value.